Yes. Good morning, my dear friends. How are you? So, let's start today's session, that is quality control, statistical and quality control. So, I'm going to start first chapter, that is your maintenance engineering, right? Here in maintenance engineering, the first concept is what? Reliability. So, what is a reliability? Reliability of a product or a system may be defined as probability that a product is performed to require what? Require a function under a specific condition for a certain period of what? Time, right? So if a product is not performing at t equal to 0, then you can say the reliability is equal to what? 100, right? And none of the product is guaranteed with the 100% of reliability. And you can say that reliability is directly proportional to the number of components which are associated. Just a minute. Let me see. Yes. Okay. Yeah. So the number of components are associated with the product. It may be in series. It may be in series configuration, and it may be in parallel configuration. If the components are in series configuration, then how can you find the reliability of a product if a components are associated in series? Then let's say here you can see that these are the components, right? These are the components, component number 1, component number 2, and component number 3, and this is my product. This is my product, and I want to calculate the reliability of my product, right? As the number of components are attached in series, so the reliability is very simple. Here you need to multiply the reliability of each component, right? Sorry, you need to multiply the reliability of each component, then you get the reliability of product, or you can say a system. Product, or you can say a system, right? So in this way you get the reliability of the product. Reliability may be equal to the reliability of the product also, but in this case reliability must be equal to what? Reliability of the product, that will be 100%. Reliability of component 2, that will be in 100%. Reliability of component 3, that will be 100%. Then you can say that reliability of a system is equal to what? 100%. Otherwise reliability is less than equal to what? Reliability of the component which are associated, right? Which are associated. Now the number of components in series is increases. As the number of component in the series increases, reliability will goes down, right? So here if you want to increase the reliability, then we go to the parallel configuration. This is a parallel configuration. In the system, this is a component, and along with that component we add the another component in parallel configuration, right? In parallel. So how can you get the reliability of a parallel configuration? That is, the system reliability is, this is a system, the system reliability is R1 plus the component which is backup of the R1, right? The reliability of the backup component R2 multiply 1 minus R1. Suppose that this is a component. Now what is the reliability? The reliability is very simple. The reliability is very simple. Let me rewrite it again, right? Let me rewrite it again. This is, you can say, a series and both series and parallel configuration. So reliability of the system is R1 multiply bracket R2, right? R2, okay, plus the backup, that is R5 multiply 1 minus R2, okay, multiply. Then R3, then the reliability of this, that is in parallel. So multiply bracket R3 plus backup, that is R6, 1 minus R3 multiply R4. So you will get the reliability of the system. Now, how can you predict the reliability? Okay, you can also predict the reliability by series and parallel configuration. Also, the reliability can be predicted by using what? Exponential distribution. So this is exponential distribution by which you can calculate the reliability of a product. The main thing is that you need to remember the formula, okay, formula of the exponential distribution. I mean, how to calculate the reliability with the help of exponential distribution. The formula is this one, that is reliability at time t of a system equal to e to the power minus lambda into t. Lambda is what? The failure rate. Lambda is what? The failure rate, and t is the time. Okay, t is the time at which you want to calculate the reliability. So the reliability is e to the power minus lambda t. Now this formula is taken from the bathtub curve. Yes, bathtub curve, that I will explain later. Now lambda is what? Failure rate, as I told you, which is number of failure divided by time, that is a during time. So n is what? N basically number of failure of a component over a period in which, right, in which it's operated for a time t. Okay, please remember this formula, it is very important. Here some terms you must be remember, that is mean time to failure, mean time to repair. What is mean time to failure? Here mean time to failure is simply the average of all time to failure, right? If a component is run for 3000 hours, then it fail. If a component run for 4000 hours, then it fail. If a component run for 7000 hours, then it fail. If a component run for 1000 hours, then it fail. Then what is the mean time to failure? That is sum of the running time divided by number of failure, right? So mean time to failure is simply the average of all time to failure. The average time an item may be expected to be the function, okay, that is below failure. Now this mean time to failure is calculated for such item which are not repairable. Yes, those are use and throw. जो use and throw होते हैं उनके लिए mean time to failure कैलकुलेट किया जाता है. तो आपको एक ये पॉइंट याद रखना है, यहाँ पर ये पॉइंट याद रखना है. This is for item that cannot be repaired. Now mean time to repair, the expected of the time, okay, mean time to repair basically calculate किया जाता है repairable item के लिए. It can be calculated for repairable item. Let me rewrite. ये calculate किया जाता है for non repairable item, and ये calculate किया जाता है calculated for repairable item. Calculated for repairable item, right? Repairable item जो like heavy machines or like machines, है ना? So mean time to repair, the expectation of the time to failure of an item. So mean time to repair is what? Time to repair, I mean how much time is taking. सपोज किसी प्रोडक्ट को रिपेयर करने में T1 टाइम जा रहा है आफ्टर फेलियर, T2 टाइम जा रहा है आफ्टर फेलियर, T3 टाइम जा रहा है आफ्टर फेलियर. Sum of all time to repair divide by the number of time, right? The number of time. So that is mean time to what? Repair. Now mean time to before failure. Let me write it again. Mean time to before failure. It is before failure. Now what is mean time to before failure? Mean time to before failure refers to time between failure for obvious reason. Okay, obvious reason. It is also calculated for a repairable item. This mean time to mean time to before failure is calculated for repairable item. I think I have written repairable item, right? Mean time to before failure refer to the time between failure for obvious reason. Here also mean time to before failure is total device hour divided by number of failure. Let us consider an item failed to sell 4 times, right? Over a period of what? 1,60,000 hours. If a component get failed, if a component get failed 4 times, if a component get failed 4 times over a period of what? Over a period of 16,000, then what will be the mean time to repair? That will be 16,000 divided by 4, that is equal to 4,000 hour is mean time to before failure. Okay. The next relation is, that is failure rate. What is the relation between failure rate and mean time to before failure or mean time to fail? Here you can see that failure rate, that is lambda, is also equal to 1 by mean time to before failure, or you can say 1 by mean time to failure, right? Now let's see the types of maintenance. There are 3 types of maintenance basically: reactive or breakdown maintenance, second preventive maintenance based on time, and third is predictive maintenance. Let's see here one by one. So reactive or breakdown maintenance is what? It is basically mean run it till it's break. You mean you are using the product till that it is going to be what? Fail. After that you will provide the maintenance, right? So here there is no need to provide a continuous monitoring. Okay. Also here cost involved with the repair or replacement of equipment. Either a component get failed, okay, so you need to replace it or you need to repair it. So reactive maintenance focus on restoring the equipment to its original position, or you can say to its normal operating condition by repair. Okay, that is reactive maintenance, that is reactive or breakdown maintenance. Now preventive maintenance, as name indicate, that it prevent the failure. So in a regular interval of time, we provide some maintenance so that total failure can be avoided, right? Total failure can be avoided. So preventive maintenance, that is based on time. It is a set of activities that are performed on a plant equipment. This basically we are plant. We are going to plant. After how much time okay, after how much time we provide what? Maintenance. Okay, so we perform a plan, equipment, machinery or system before the occurrence of what? Before the occurrence of failure. Please note that before the occurrence of what? Failure, in order to protect them and prevent them. So basically we are doing a routine checkup or routine servicing, right, on in a regular interval of time. So it is a routine service or plant schedule to prevent the failure. At a particular interval of time, we did a routine checkup, and if it required, then we provide the maintenance. Here the primary goal is to enhance the equipment reliability. If the equipment get the service in a regular interval of time, then the chances of failure get reduces, its reliability increases, right? So it includes the performance of unneeded maintenance. If you provide the regular maintenance, then there is no need for unneeded maintenance here. Okay, next is predictive maintenance. Here predictive maintenance basically is what? Predictive maintenance basically, you can say that time be replaced based on condition monitoring of a component. Basically by observing, if you found any, basically on the basis of observance, if you found any disturbance, like by hearing the noise, right, like by temperature, by vibration, if you found any disturbance, then you provide the maintenance. That is known as what? Predictive maintenance. So timely replacement based on condition monitoring means you are watching what? Condition. You are watching the condition, and condition could be anything. Suppose that the component of a machine produce lot of noise. Suppose that the machine's temperature unnecessary get increases, right? Suppose that the machine part produce unnecessary vibration. So on the basis of condition, you provide the maintenance to avoid the total breakdown. Okay, so it detect the system degradation, right? It is needed for the maintenance task before the equipment maintenance task based on equipment condition or before the failure, right? Before the failure. So next is bathtub. Let me show you the bathtub. Bathtub basically divided in two phases. As you can see, this is a bathtub, right? It's look like this. The curve is look like this. It is categorized. It is divided into three parts. First is infant mortality failure. Second is constant failure rate, and third is wear out failure, right? Infant mortality period is basically if the component is new, right? It's known as early failure stage or debugging stage. If some error comes because the component is new, so it is obvious that some error will become. So at the beginning, if error is come, then the failure will be unpredictable and at a very high rate, right? At the beginning, failure rate is high, but as the time goes on, the failure rate get what decreases or gradually decreases with time. So failure occur. Why failure is occurring in the infant mortality stage or in the first stage? Basically, due to engineering product does not test sufficiently. Basically you haven't done sufficient R&D on the product, or it may be manufacturing defective product. If some defect has come, if some early defect has come, then it might be possible that infant mortality period will come. Incorrect positioning of parts. If you are not aligned all the parts, if you are not aligned properly all the parts in machine, then it might be happen that the failure rate initially is high. After some time of period, the failure rate get to what constant, that is useful life. Here the failure rate is remain constant. You should be remember this point. The constant failure rate can be predicted by exponential distribution. By what formula? By this formula. Remember, by this formula you can calculate this formula, e to the power minus lambda t. Okay, e to the power minus lambda t. By this formula you can calculate the useful life or reliability, e to the power minus lambda t. Okay, now we are okay. Now my voice is coming. Yes. Now Kaizen. Kaizen means continuous improvement. Kai means change, and Zen means for the better. You are doing changing for the better. You are doing continuous changes for the better. So here you can see Kai means change and Zen for better. Right? Now Kaizen has a Now I think I'm audible. Okay. Now everything is sorted. Now what I was telling, the next chapter is sampling plan. So it is a technique in which samples are drawn at random and we do the inspection. Right? We do the inspection. So sampling inspection is not measuring the quality of the lot. Not measure the quality of the lot. So here please remember that the sampling inspection, okay, measure which is not decide the quality of the lot, but it gives the sentence whether we have to reject or accept it, whether we have to reject or accept the lot. Suppose that if you do 100% inspection, means quality of a lot basically a sample is there. Okay, a sample is there that is of 1 lakh. That is of what? 1 lakh unit. So what we do from the lot, we take a sample. We take a sample. We take a sample. This is a lot, right? We take a sample. Let's say n equal to what? N equal to 20 units, and we do the inspection. So we are not doing here 100% inspection, and on the basis of the inspection of sample, we decide whether we have to accept the lot or whether we have to reject the lot. This will not decide the quality. It decides whether we have to accept or reject. Okay. Then you can say that, sir, if we select randomly at 20 unit, then it might be possible that some defective unit may be present in the rest of the lot. Then in that case, you need to do what? 100% inspection. And the 100% inspection is not possible by human. Right, right. Even a machine. If you do 100% inspection, then lot of time get consumed. Okay, and time is what? Time is money. So acceptance quality level has less meaning in 100% inspection. Since a target of your is what? Target of your 0x defects. 0 defects should be attainable. But okay, attainable if each part batches inspected. But there will be two problem. Inspection become costly. You can do it by machine, right? But inspection become what? Costly. And there are always error associated with what? 100% inspection. If you do a same work back to back, then there is a chance that you will do a what? A mistake, right? Then you can do a mistake. So here the next subtopic is what? Acceptance sampling. So acceptance sampling basically, yeah, acceptance sampling basically percentage of defective item, okay, percentage of defective item which you can accept in a lot. So it is an important field of SQC. SQC is what? Statistical quality control, which decide the quality of a lot. So it is an important field of what? SQC, that is statistical quality control. Okay, SQC inspection. So it is known as middle of the road because it is in between 0% to 100%. Right, you are not doing inspection of all unit, you are selecting some random units. So it was popularized by one of the next point is you must be remember, it was popularized by what? Doge and Roming. Okay, acceptance based on what? That is on attribute and that is on variable. Attribute and variable, you need to remember those only two things. Acceptance based on what? Acceptance based on attribute, which is count, and acceptance based by variable. Here we cannot count, we can measure only, like thickness, strength and weight, right? So here there are two type of sampling plan: single sampling plan and double sampling plan. This is a single sampling plan and this is double sampling plan. So in single sampling plan, let's say there is a lot, okay, there is a lot and we are accepting X is a number of defective item, or you can say D is a number of defective item, okay, and C is the acceptance number, and small n is the sample size which we are taking from the lot, and capital N is a lot size. So here if the capital N is a lot size, here this is a lot, okay, capital N, and let's say this is a 10 lakh unit lot size. So it is not possible to inspect each and every component. So what we do, we take a sample of random, sample of 100 unit at random, and we do the inspection. If the number of defective item is less than the accepted, is less than the accepted error, okay, is less than the accepted number of error, then we accept the lot. But if the number of defective item is greater than accepted number of defect, then you need to reject the lot. So this is very simple, a single sampling plan. In another case, there is a double sampling plan. What we do in double sampling plan, let's say a lot of 10 lakh units, a lot of 10 lakh units, and we randomly draw 100 units, right? And we did the inspection. There might be a two case. There might be a two case. The defective, the number of defective should be greater than equal to the minimum defect, and the number of defect should be greater than equal to the maximum accepted number. There might be two cases that number of defect should be less than equal to the minimum accepted number, or the number of defect must be greater than the maximum expected number. If it is less than minimum accepted number, then we accept the lot. If it is greater than maximum expected number, then we reject the lot. But what happen if the defect which you found here, if the defect, this D1, let's say this is D1, okay, here let me write it again. Let's say D1 is the defect which is less than equal to C1, and again D1 is the defect which is greater than C2. What happen if the defect is greater than C1 but less than equal to what? C2. Then in this case we take another sample from rest of the, that is capital N minus small n. We take another sample from rest of the lot, that is capital N minus small l. And if we found a defect that is D2, and here the previous defect D1, okay, previous defect D1 plus D2 is less than C2, that is maximum acceptance number, then we accept the lot. And if previous defect plus the newly defect found in rest of the capital N minus small n defect, and it is greater than maximum acceptance number, then we reject the lot. So this is what? This is a double sampling plan. Next is basically in sampling plan, there is a operating characteristic curve. So there are few terms which you must be understand. So let's go to the okay types of error. There will be two types of error if you do the sampling. What is type 1 error? That is reject a good lot. Type 1 error, that is reject a good lot. Type 2 error, that is accept the bad lot, right? Type 1 error, that is reject the good lot. Type 2 error, that is accept the bad lot. Now type 1 error, let's talk about the type 1 error. It is associated with the producer risk. Yes, it is associated with the producer risk, which is represented by what? Alpha. So its true value is AQL, that is acceptance quality level. I will show you in the graph. And its common value is 5%. Now type 2 error is what? Accept the bad lot. Okay, accept the bad lot. If the bad lot is going to be accepted, then it will be consumer risk. Which is denoted by what? Which is denoted by beta. Its true value is RQL, that is rejected quality level. Means you are accepting the rejected quality level, and in the previous case you are rejecting what? Accepted quality level. Okay, here type 2 error, its true value is 10%, right? Is 10%. Let me show you the curve. Yes, this is a curve. Here you can see a curve. This is on x-axis. There is the basically percentage defective item, and on y-axis there is a probability of acceptance, right? On y-axis there is a probability of acceptance. So here the graph basically used in quality control to determine the probability of what? Probability of acceptance, probability of accepting a product lot, and obtained by performing sampling inspection. This graph is discrimination of sampling plan between good lot and bad lot. The good lot, that is AQL. Here you can see that this is AQL. This is acceptable quality control, whose probability is this much. Whose probability is this much. Right, a lot which has minimum number of defect or good lot, okay, has probability of this much, that is 95%, and the rejecting chance is what? That is your producer risk. This is the producer risk. See here, this is a producer risk, that is alpha. That is alpha. The value is what? Alpha, the value is 5%, and it is what? It is the producer risk. Producer risk, that is rejecting the accepting quality level, right? Accepting quality level. If the lot has, okay, lot of defect, okay, lot of defect, let's say this one, lot of defect, right? That is a lot of defect, okay, then the probability of accepting is less. This is the probability, less probability of acceptance. If the same lot get accepted, okay, then it will become your consumer risk, that is beta. Consumer risk, okay. Consumer risk means you accepted a rejectable quality lot, okay, you are accepting the rejectable quality control. So it measures the performance of acceptance sampling. You must remember some terms are associated with that, which you must be know. That is acceptance quality level. So it is define the performance of defect at which consumer are willing to accept a lot as good, right? So AQL is also termed as producer safe point. Okay. Now the next is LTPD, that is lot tolerance percentage defect, or rejectable quality level RQL. It defines the upper limit on the percentage of defect that quality level unacceptable to the customer. Unacceptable to the customer. And here customer are willing to accept as good, that is AQL, acceptable quality lot, okay. The next term is producer risk. If the AQL get rejected, if the AQL lot get rejected, then you can say it is a producer risk. If the RQL get accepted, then you can say it is a consumer risk. So producer risk, a lot contain the acceptable quality level, but it will be rejected. That is the producer risk. Consumer risk, that is beta, a lot contain defective exceeding the RQL. I mean, a lot which has the number of defect which is more than RQL will be accepted. That is what? That is the consumer risk. Okay. And the lot which has the defect more than AQL and less than RQL is known as indifferent quality level. Indifferent quality level. So indifferent quality level comes in between. This is a indifferent quality level whose probability of acceptance is nearly 50%. Whose probability of acceptance is nearly 50%. Okay, nearly 50%. Now let's move. Yes, nearly 50%. So indifferent quality level between somehow or somewhere between AQL and RQL. It frequently defined as the quality level having a probability of acceptance of 0.5 or 50% for a given sample. That's it. Okay, so this is that's all. The next is ideal OC curve. The ideal OC curve is look like this. It is perpendicular to the fraction of defect. So ideal OC curve, okay, ideal OC curve basically when you are doing 100% inspection. Practically it is not exist. Practically it is not exist, but ideally you can talk. Ideally OC curve is what? Obtained by 100% inspection only. Ideal OC curve would be perfectly perpendicular from a given ideal OC curve would be perfectly perpendicular to the fraction of defect. Fraction, okay, fraction defective. That's it. Okay. Now the next is, yes, the next is your OC curve. How OC curve get vary? My dear, the OC curve may be affected by changing the sample size, right? By changing the sample size. When you increase the sample size, it becomes stepper. You can see here the sample size is what? 20. You can see here the sample size is 20. Here the sample size is 50. So the OC curve which has a more sample size, it become what? More steeper. More steeper. Or if you increase the, okay, or if you increase the sample size, it become steeper. Also, if the acceptance number get increases, if the C get increases, then what happen? If C get increases, then producer risk get decreases and and consumer risk get increases, right? Your producer risk get decreases and consumer risk get increases. So this is the relation. You must need to remember this. Okay. Now the next chapter is quality. The next chapter is what? Quality. I hope there is no doubt till that, because as you know it is a crash course, so we are compressing all the thing in a small capsule. Right. So here I'm only showing some important point and I'm showing you and I'm giving you a theory, a crisp theory, okay, to you, right? So quality is what? It is defined as the degree of customer satisfaction. Yes, it is defined as the degree of customer satisfaction. How much customer is what? Satisfied. Now customer can be satisfied with the quality of design, with the quality of conformance, and with the quality of performance. So quality, the type of quality. Now you need to be remember the type of quality. You don't need to go in depth of the quality of design. What is quality of design? What is quality of conformance? What is quality of performance? Quality is what? It is defined as the degree of customer satisfaction, right? How much customer is satisfied, and the customer will satisfy on the basis of 3 parameter. That is quality of design, quality of conformance, quality of performance, right? Quality of design is what? Engineers add some feature, okay, during design of the product. Quality of conformance means, it means how well the product meets the specification. If you are adding some features, then how well that feature meets its specification. Quality of performance, it's associated with the reliability of product. That's it. But you need to remember only 3 points. Quality is what? Quality is degree of customer satisfaction. Types of quality, that is quality of design, quality of conformance, quality of performance. That's it, right? That's it. Now here the next important point in quality, that is cost. The cost which is associated in quality, right? The cost that is associated in quality. So cost of quality, this is the chart, okay. So it is easy to remember that cost of quality, that is subcategorized into 2. Cost of good quality, I will explain it, don't worry. Cost of quality, that is cost of good quality, and cost of poor quality. Cost of good quality is conformance, cost of poor quality is non-conformance. Now cost of good quality is divided into cost of appraisal and prevention cost, and cost of poor quality is divided into internal failure cost and external failure cost. Okay, internal failure cost and external failure cost. Now cost of conformance. What is cost of conformance or cost of good quality? Okay, What is cost of good quality? That is cost of conformance. The cost of providing, please remember, the cost of providing product as per the required standard. You are providing the product as per the required standard. You are providing the product. You are providing the product. Providing the product. Providing the product as per standard. As per standard. Right? As per standard. The cost of providing the product as per required standard means whatever standard you promise, and the cost which maintain that standard is known as cost of conformance. It may be of two type, that is prevention cost and appraisal cost. What is prevention cost? Prevention cost. Prevention cost and appraisal cost. Okay, let's discuss the appraisal cost. Basically, appraisal cost is a cost, okay, that remove any defect before the failure, or that remove any you can say any part, that remove any part before failure in the system. The cost of the activity or a activity, the cost for the activity to assure that there is no defect, okay, there that no defect are found, right? So if you give the certificate to the product that there is no defect, then automatically the cost of the product get increases, and whatever the cost associated with that activity is known as what? Appraisal cost. So you can say it is an inspection cost, you can say it is an audit cost, you can say it is a checkup cost, right? So appraisal cost is nothing. You are auditing something and giving that certificate that the product has or system has no defect. Okay, so auditing cost, inspection cost, right? Now prevention cost. What is the prevention cost here? Prevention cost basically any cost related to reduce or removing the presence of quality issue, right? Basically there is no space, but if I write, what you need to be remember, cost related to reducing, related to reducing, related to reducing what? Related to reducing or removing the presence of, or removing the presence of quality issue. Quality issue, right? Presence of quality issue from the outset. So risk analysis, this is a risk analysis, this is the quality assurance and corrective action work. And corrective action work to prevent future defect, from occurring are considered as prevention cost. Okay, the next is cost of failure. The cost of failure, that is a non-conformance, is divided into internal failure cost and external failure cost, right? It's divided into internal and external failure cost. What is cost of failure? The cost associated with the process not operating. The cost associated with the process not operating according to requirement. Not operating. The cost associated with cost of failure. Okay, the cost associated with the cost associated with what? With the process not operating, with the process not operating, right? Not operating according to requirement, not operating according to requirement. Okay, it can be subcategorized into two parts, that is internal failure cost and external failure cost, right? Internal failure cost and external failure cost. Internal failure cost arises. Internal failure cost arises when work is failed before the transfer to the customer. Means you are giving, suppose that you are giving the product, but before giving the product to customer, a failure comes. Internal failure cost arises when work is failed before transfer to the customer, like company is transferring you, or company is delivering you a car, and before delivering, a scratch comes, right? A scratch comes on your car, a scratch comes on your bike, a scratch comes on your furniture before transferring to the customer, right? External failure cost, it arises when the product is delivered. It arises when the product is delivered to the customer, right? Okay, after delivery, the failure cost may become, right? If the product may be failed, so it will be covered under warranty cost, under guarantee cost, under inspection cost, right? So that's it here. Types of cost is covered here. Okay, types of cost is covered here. Now I'm coming to the goal of quality cost system. I hope everything is clear till now. So what is the goal of quality cost system? Basically, the goal of quality cost system is what? The cost of failure, that is decline, as a conformance quality level improves toward perfection, while the cost of appraisal plus prevention cost, there is some optimum target quality level where the sum of prevention plus appraisal and failure cost is at a minimum level. Basically, we the moral of the summary is that the moral of the topic is that we are providing optimum quality in minimum cost, right? My dear, this session is not helpful for GATE. First of all, this session is helpful only for ESE as it is written in the topic. As you are the educated person, it is written in our YouTube headline, that is a standard and quality practice one shot journal studies UPSC ESE Prelims 2026. It is not useful for GATE. Okay, from theory point of view, for your college point of view, it might be helpful, but not for the exam point of view. Okay, so where am I? I was telling that you are getting optimum quality level at the minimum cost. The moral of the topic is that you are getting optimal level of quality at the minimum cost. As simple as that, right? As simple as that. Now, quality management, there are some quality management gurus. Okay, there are some quality management gurus. W.E. World Deming. Okay. So he is the father of quality control circle, also known as Japanese post-war industrial revival. He is the Japan post-war industrial revival. Okay. There is a prize, that is a Deming prize. Okay. Here it defined that quality. He defined the quality. What he say? Quality is every one responsibility, not a single person, right? Not a single person. His major contribution is to, he define a Deming cycle, which I'm going to tell you, 14 points of management and 7 deadly disease. Okay, you must remember only this Deming cycle. Rest of us is not useful. Okay, only this is sufficient. This is sufficient Deming cycle, which I tell you. Now, what is Deming cycle? This is a Deming cycle. As you can see, this is important. Deming cycle, right? It provide a framework for the improvement of process. It provide the okay. It provide a framework for the improvement of process and system. Okay, Deming cycle is defined by PDCA. PDCA circle. What is P stand for? Plan. D stand for do. C stand for check. A stand for act. That is plan, do, check, act. Right? You just remember the Deming cycle. Plan, do, check, act. PDCA. Okay. PDCA. That's it. That is the only important thing which you must be remember. What is Deming cycle? PDCA. What is PDCA? Plan, do, check and act. That's it. Plan, do, check and act. The next is PDSA. Okay. The second cycle is Deming cycle. As Deming has two cycle, PDCA, and the next is PDSA. What is PDSA? P as it is plan, right? P as it is plan, D as it is do. Now here, instead of C, there is S. That is study and act. There is study and act. So remember that PDSA and PDCA. PDCA is plan, do, check, act, and PDSA is plan, do, study, act. Okay, plan, do, study, act. That's it. Okay, now there is a second person who is known as Joseph Juran. Joseph Juran has Joseph Ziraf is also a quality guru, right? He defined the quality. Quality goes not happen by accident. Quality does not happen. Sorry, quality does not happen by accident. Quality basically you need to do a contribution, right? In quality, and Joseph Juran give his contribution in quality trilogy. What is quality trilogy? Quality planning, quality improvement, and quality control, right? Joseph Juran given quality trilogy, that is quality planning, quality improvement, and quality control. Joseph Juran work on Pareto principle for quality issue, right? That is 80% of the problem. What is the Pareto principle? 80% of the problem is caused by 20% of cause. 80% of the problem is caused by 20% of the cause. This is known as the vital few, trivial many. Vital few, trivial many. Right? Vital few, trivial many. Next is Philip Crosby. Phyllis Crosby basically a fun uncle of quality evolution. Here idea the cost of poor quality. He contribute zero defect, cost of quality, and quality is for everyone responsibility, right? So that's it. Now I will come to quality control tool. Okay, quality control tool. Basically, by the using of quality control tool, we are monitoring the quality level. Quality control tool is what? It is the tool by which you are monitoring the quality level. So it is given by Koro Ishikawa. It is given by Koro Ishikawa, right? There is a histogram. A histogram is what? A graph that show distribution of data, right? A graph that show distribution of data. Before that, we use the bar graph. Later, there is a histogram. So it is used to determine the spread and variation of data with the time or with another variable. Here it is used to find any unusual thing which happened during the process. Because if you see the graph, then you can easily notice. If you see the graph during process, then you can easily determine any unusual thing by seeing the graph only. So here value is distribution, and the range of those value is given in the graph, right? Now there is the second tool, that is Pareto analysis. What is a Pareto analysis? As I told you, this is 80-20 law. That is 80-20 law given by what? Given by Wilford Pareto. Given by Wilford Pareto, it is 80-20 law. Later adopted by Joseph Juran. Later adopted by Joseph Juran. Right. The statement is, remember the statement also. 80% of the problem, 80% of the problems are created by approximately 20% of the cause. Approximately 20% of the cause. So this is the statement of 80-20 law or Pareto analysis Okay. Okay, so here you can say that if you want to understand by some example, you can say that 80% of India's revenue, 80% of India's revenue is in the hand of 20% people, right? If you want to apply this Pareto analysis, okay, in some example, then you can take an example that 80% of India's revenue is in the hand of 20% of the people. So Pareto chart is one of the key tool. Pareto chart is one of the key tool, okay, used in quality control and Six Sigma. Later we are going to discuss Six Sigma. So as I given the example, 80% of the India's revenue is in the hand of 20% of the people, and Pareto chart is a useful tool which play important role in quality control and Six Sigma as well. Okay. Now there is the flow chart. Flow chart are what? As I earlier I told you, we are dealing with quality control tool. So they are the tool by which you monitor the process, by which you monitor the quality, okay, of the process. So flow chart help in identifying point or bottleneck. Bottleneck is a point where the process is very slow. Okay, okay, identifying a point or bottleneck where the problem might occur. Any unusual thing you can notice by the flow chart. So use the graphical symbol in flow chart. We are not write every time. We are not going to write every time in the flow chart. Instead of that, we use some symbol, right? We use some graphical symbol to deplete the nature of flow, the nature of flow of the process, right? It allow anyone to view the flow chart. It allow anyone to view the flow chart and logic flow in the process. It can be used to find a problem, any unusual thing. So what are the symbol which we can use? That is a symbol represented by it is represent operation. That symbol represent inspection. That symbol represent what? That symbol represent transportation. That symbol represent delay or temporary storage. That symbol represent storage. That symbol, it's a combine of two symbols. So operation and inspection is going on. It is a combine of two symbols. It represent operation come transportation occur here. Okay. There is no need of checklist. The fishbone diagram is very important. Okay. Here the fishbone diagram is very important. Basically in fishbone diagram we get the cause of the problem, right? Why we called a fishbone diagram? Because in problem there are various cause which attach to its tail just like a fish backside. Okay, so fishbone diagram, or you can say it is also called a cause and effect diagram, and you can say Ishikawa diagram. It enable a team to focus on the cause of problem, right? These causes are attached just like a fish. This is the head of the fish, this is the backside of the fish. People, material, caused by people, caused by material, caused by process, caused by equipment, okay, and it become a problem for a system. So it enable a team to focus on the cause of problem. Its graphical chart used to list potential cause of a given problem. What are the potential cause? It might be people, it might be material, it might be process, it might be equipment, right? So please remember this graph. Okay. Now the last is control chart. Control chart of various type. You don't need to remember the formula of the control chart. You must remember the type of control chart. Control chart are of two type: charts for variable and charts for attribute. Control charts are of two type: charts for variable and charts for attribute. Now charts for variable, that is average chart, okay, and range chart. In average chart, charts for variable, average chart and range chart. For average chart we use X chart or X chart. Range chart we use R chart or R bar chart. Charts for attributes are categorized into two, that is charts for defective item, charts for defective items, and charts for defective per item. Charge for defective item. In this category, the fraction defective will be considered. Means here sample size get varied. In a sample size get varied, and we study the number of defect. Second is number of defective. Here the sample size is constant. Okay, and our focus is number of defect. Here charts for defective per item. It is a constant sample size, that is C chart. Okay, so fraction defective chart. In fraction defective chart, we use P chart. Please remember P chart. In number of defective, we consider NP chart. We consider NP chart. Charts for defective item are basically we use C chart and U chart. Only remember this tree. Only remember this tree. It is more than sufficient to you. Okay, it is more than sufficient to you. Now let's move to the Six Sigma. Let's move to the Six Sigma. Okay, here in Six Sigma, basically we are again seeing the quality of product, right? Quality of product. So the father of Six Sigma is Bill Smith. Father of Six Sigma is Bill Smith, right? Sigma measure the deviation from perfection. Okay, from perfection, a process is how much deviated. Okay, so there is a particular limit. The deviation is allowed to the particular limit from the perfection. So sigma is what? Sigma is a methodology and symbol of quality. Sigma is purely scientific method which used to process environment, and this method is known as DMAIC. Now the question is, sir, what is DMAIC? Okay, D means define. D means define, right? D means define. Okay, M means measure. M means measure. A means analysis. Define, measure, analysis. I means improve. And C means control. So sigma is purely scientific method which is used for process improvement, and this method is known as DMIC. What is DMIC? Define, measure, analysis, improve, and control. The main focus is a quality improvement and bring the defect rate 3.4 parts per million. 3.4 parts per million. Okay, what is PPMO? Parts per million opportunity, right? Parts per million opportunity. It means that 3.4 item defective in what? 10 lakh sample, right? That is the motive. Okay, that is the motive. So basically we are minimizing the error to 0. So the idea behind Six Sigma is what? To get the 0 defect. It is, you can say that it is a 0 defect sample. Okay, it has what? It has a 0 defect sample. So sigma means it follow a normal distribution with a variable sigma. Okay, so here the meaning of Six Sigma is 99.997 defect free item, only 3.4 item, okay, in 10 lakh samples. As you can see that sigma level, this is sigma 1, this is 2 sigma, this is 3 sigma, 4 sigma, 5 sigma, 6 sigma. DPMO, that is defective part per million opportunity. So here you can see that if you consider 6 sigma, then only 3.4 defective item, only 3.4 defective item out of 10 lakh unit, which gives the process yield of 99.9997%. Okay, so then you will say, sir, why don't we go to the 7 sigma, 8 sigma? My dear, it become costlier, right? If you increase the sigma, then the cost of inspection become, okay, increases again. Okay, Now, Six Sigma methodology, DMIC. So in Six Sigma methodology, there is one DMAIC. The second one is DMADV. Okay, okay, and let's proceed it later. Yeah, what is DMAIC? I already told you. D stand for define, measure, analysis, improve, and control. Okay, okay, and control. So here what we are going to do, a way to improve the work process by eliminating any defect if it is present. It is used for existing process only. It is used for existing process only. Okay, there is a logical structure. There is a logical structure. Okay, approach to problem solving. There is a logical structure, approach to problem solving and process improvement. So it is a continuous process, right? It is a continuous process which apply for the existing process. Okay, which apply for the consisting. Now, what is DMADV? DMADV, that is define, measure, analysis, design, and verify. It is used for a new process. It is used for a new process, and earlier one is used for the existing process. Whereas the DMADV is used for new process, okay, or improving the existing process rather than simply fine process, okay, rather than simply fine process. Now, there is a DOE, that is design of experiment. So design of experiment is what? Is statistical test. It is a statistical test, okay, determine cause and effect relationship between process variable and output. So there will be a Six Sigma certificate. It has the different level of Six Sigma, that is white belt, then yellow belt, green belt, black belt, master belt, and champion. Okay, master belt and champion. If you want to see what is white belt, they are not fully involved in Six Sigma project. Suppose there is a project, they are not fully involved. They basically they see the project. They are allowed to see the project only, right? They are allowed to see the project only. Okay, they learn. Basically, they are in the learning phase. As you can say, they are in the learning phase. Okay. Here, yellow belt holder, yes, here, yellow belt holder give training to the white belt. Okay. It is not fully recognized by entire Sigma. As you can say, they are the trainee people. Now, the second is yellow belt. In yellow belt, serve as a team member serve as a team member on the Six Sigma project. Okay. Second is having a basic knowledge of Six Sigma, having the basic knowledge of Sigma, but not lead the project on their own. They are not able to lead the project on their own. They are responsible for development of process map to support the Sigma project. They develop the road, okay, on which the project will proceed. Okay, they are responsible for running a small process only. They are responsible for running a small process only. Now there is a green belt. In green belt, green belt manage the project on the part-time basis. Here, the green belt emphasize on DMAIC model: define, measure, analysis, improve, and control. Okay, green belt, okay, can lead a small scale improvement project. Green belt can be a part of project team member. Now there is a black belt. Black belt prepare you to lead a complex Sigma project. They are having a complex understanding of DMAIC or DMAP. They are project team leader. They provide coaching to yellow and green belt people. Okay, they are full time committed. They are responsible for on time performance and meeting goods. Now the next is your master black belt. These are the master black belt. Master black belt develops, basically they are a developer of curriculum, experience in managing several projects, and deep experience of Sigma. They offer mentorship and coaching for the black belt level. They manage, they maintain a project work. Okay, they have extensive knowledge about channel concept, lean enterprises, and zero defect. Last are champion, which are the top of the pyramid. Champion is the senior. Champion is a senior or medium level executive whose role is choosing and sponsoring the project. Right? They basically champions are responsible for overall Six Sigma pictures with an organization and acting as a mentor or guide. As a person, as a person or the team who know business at hand, inside and outside, and also know the methodology of Six Sigma. Right? So I hope this thing is clear. Black belt, white belt is clear. Champions are clear. Now let's come total quality management. Okay. Total quality management. So far we have completed five chapters. So far we have completed five chapters, and the next chapter is total quality management. Total, basically the involvement. Taguchi and Ishikawa I have covered. Taguchi will become. Don't worry. Total. What is total? Total basically in the topic you can see there is a term. The topic is what? Total quality management. So what is total? Total is the involvement and input of everyone. What is quality? Full meeting customers needs and requirement all the time. Management, the way we act, operate, control it. Okay. So TQM is a culture. It is not a program. It is not a program. It is not the collection of tool or technique, right? It is used to achieve continuous improvement. It is used to achieve continuous improvement of the quality and service, right? It's based on customer satisfaction. Is based on customer satisfaction. Now, there is two type of approach in TQM, that is a small q and big Q. In a small q, you can say it is a traditional approach, and big Q, that is the TQM approach. Traditional approach and TQM approach. In traditional approach, customer needs are not received by. In simple word, what is traditional approach? In this approach, customer needs are not covered by the company, but in TQM approach, customer needs are covered by the company because they focus on a strong customer satisfaction, right? So in a small q or traditional approach, it is based on past production defect, okay, detection philosophy. If in the previous manufacturing, if there is any defect, then they focus only on that. They will not focus on the customer feedback. Here sir will under the monopolistic situation where both organization and customer are treated as what? Black box, means they don't know what is going to be happen. So customer need not received by the company. Customer needs are not, again and again I am saying, the only important point is that in traditional approach, customer needs are not received by the company. Okay, that's it. But in TQM, they focused on a strong customer satisfaction. In TQM, they focus on strong customer satisfaction. That's it. Now there are principles of TQM. It has mainly 8 principles. First is leadership. Second is customer focus organization. Third is involvement of people. Fourth is process improvement. Fifth is system approach to management. Sixth is continuous improvement, that is Kaizen, which we studied. Seventh is factual approach. Seventh is, let me show you. First is leadership. Second is customer focus organization. Third is involvement of people. Fourth is process improvement. Fifth is system approach to management. Sixth is continuous improvement, that is Kaizen. Seventh is factual approach to design making. Eighth is mutually beneficial supplier relationship. Right? Now, here, Taguchi. Yes, Ashwini Kumar. Taguchi approach in TQM. So, Taguchi approach. What is Taguchi approach in TQM? Okay. He developed two things. First is robust design. Second is Taguchi loss function. Robust design. Okay. First is robust design. So, robust design. According to Taguchi variation. Okay. According to Taguchi, a variation is, can be noise factor. Okay. Robust designs means continue to produce good product with minimum variation. Noise factor is a source of variation which is difficult to control. Okay, which is difficult to control. Here, the type of noise factor are what? The type of noise factor are unit to unit noise factor, internal noise factor, and external noise factor. Okay. 3 types of noise factors are there: unit to unit noise factor, internal noise factor, external noise factor. What is first unit to unit noise factor? It is associated with the production process. It shows variability in the material, in the machine or worker. Second, internal noise factor. Basically, it is a time dependent factor, that is wear of the machine component occur with the time. Okay. Operation errors such as improper setting of the product or machine tool. Third is external noise factor, which is uncontrollable, that is humidity and temperature. Process variation, that is external. Process variation, that is external to the product or service. Okay, that is humidity, temperature, etc. Now, here the next is Taguchi loss function. Yes, the next is Taguchi loss function. So what Taguchi state? Taguchi states that any variation away from normal, that is target, away from normal performance will begin to incur customer dissatisfaction. Again, I am repeating what Taguchi say. Taguchi loss function say. Taguchi state that every variation away from normal, that is target performance, will begin to incur a customer's dissatisfaction. Taguchi loss function can be linear, quadratic or polynomial by Taguchi. Taguchi loss function can be linear, quadratic or polynomial by Taguchi. The loss function, the loss may be due to the performance variation, is proportional to the square of the deviation of the performance characteristic from its normal value. So how can you write? You can write that Taguchi loss function, equal to a constant variation from targeted square. Okay, variation from targeted square. So basically here, what is y here, and what is y not here, and what is k? K is the constant of Taguchi loss function. Why measure the value of quality characteristic? Why not is the target value of quality characteristic? K, a constant that is depend on production parameter. L is a loss parameter. So remember this Taguchi loss function. This is the Taguchi loss function, right? A numerical may not become okay on this function, but you need to remember this. Okay, you need to remember this Taguchi loss function. Okay, you need to remember this Taguchi loss function. So this is a Taguchi loss function. Yes. Now, next I'm going to ISO standards. Okay. Next I'm going to ISO standard. So we need to, now I'm going to cover ISO standard, inventory control and non-destructive test. Okay. These are the rest of the topics. So International Standard Association. Okay. So the member of ISO are what? 164. Currently, I think 164 members are there of ISO, and yes, 164 members are there. Type of organization is what? Non-governmental organization. Where is the headquarter? Headquarter is in Geneva. Okay, Geneva, Switzerland. Its objective is international standardization. International standardization. Okay, international standardization. Now, ISO has three membership category. ISO has three membership category. First is member body. Okay, what is member body here? Member body. Yes. What are member bodies? Member bodies are national bodies. Member bodies are national bodies. Consider the most representative. Consider the most representative standard body in each country. They are the only member of ISO that has a voting right. So remember that member body are the body who have, they are the only member who have the voting right. Second is correspondent member. Correspondent member are the are countries. Corresponding member are countries that do not have their own standard organization. They don't have their own standard organization. Basically, these members are informed by the ISO. Okay, these members are informed about the ISO work, but do not participate in the standard promulgation. Okay, they informed about the ISO work, but do not participate in standard promulgation. Okay, now the third body is subscriber member. The third body is subscriber member. Subscriber member basically are countries with small economies. With small economies, they pay reduced membership fee, but earn follow the development of what? Standard. Okay. Sure, we will upload the practice sheet, my dear. Don't worry, Chanak. Don't worry. Very soon we are going to upload the practice sheet. Okay. If you copy paste, repeat and again, then there is no meaning. I have seen. Okay. We will upload the practice sheet very soon. Don't worry. Now, there are series of ISO. Okay. There are series of ISO. ISO 9000 series. ISO 9000 series. It is a series of quality management that assure the standard. It's mainly based on UK Canadian standard. It's mainly based on UK Canadian standard. Okay, it is a series of quality management and assurance standard. Okay, second is in ISO 9000, a management methodology adopted by a company. Please see here, a management methodology adopted by a company to deliver product or services that meet the customer expectation. ISO 9000 standard do not mean high level of quality, do not mean high level of quality, but it forces a company to assure its customer, that product is manufactured according to standard. It is an international standard of quality. ISO 9000 series is based on 8 quality management. Okay, is based on 8 quality management. So here ISO 9001. What is ISO 9001? For the requirement for the quality system of the supplier or satisfy the customer quality requirement, right? ISO 9002 is for the product standard. ISO 9003 is for final inspection and testing. ISO 9004 is for guideline for the implementation and developing quality system, principle, structure, auditing and review, right? Auditing and review. ISO 1400 series. In ISO 1400 series, basically it is relatable, or it is related to the environment management. It is related to environment management. Okay, so 14,000, I think it is a 14,000. So ISO 14,000 do not maintain the ISO 14,000 do not maintain a particular level of pollution or performance, but but basically but spread the awareness of the process, spread the awareness of the process and procedure that can affect the environment. There are ISO 14001, that is environment management system. ISO 14004, that is guideline standards. ISO 14010 to ISO 14015, that is environment activist. ISO 14020, ISO 14040 is a environment labeling. ISO 14050 term and conditions. ISO 14064 greenhouse gases. Right, greenhouse gases. That is not voice, this is house. Okay, house gases. ISO 14063 environment communication. ISO 19011 auditing management system. Now there is a OSHAS, occupational health and safety, that is 18,000 series. So here international standard provide a framework to identify uncontrolled and demand the risk associated with the health and safety. OSHAS 18001, it is about occupational health and safety management. It is based on ISO 9001 and ISO 14001. Remember that it is based on ISO 9001 and ISO 14001. It is used to manage. It is used management approach tool, that is PDCA, which is not visible here. It is used management approach to PDCA cycle. Okay, PDCA cycle. So that's it in ISO. Now let's come to the inventory or inventory control. Basically, what is inventory? A inventory is a place where the manufacturer place raw material, okay, semi-finished item or finished item, okay, before the delivery, or for manufacturing the raw material, material. So the quality or value of the current stock of a manufacturer or retailer. This can include a raw material and parts that will be used later in the manufacturing process. The managing of inventory is vital for the smooth running of a business or any business. And the science of inventory management is required to ensure that your supply network will be non-stop. Okay, work without hiccups. Got it? Work without disturbance, flow without disturbance. Now, The important point is type of inventory. Okay, this is important. Type of inventory is important. Although inventory is a very big topic, but you need to remember the types of inventory only. So the types of inventory, first is movement inventories, right? First is movement inventory. Movement inventory is what? Basically, every day resources are being transported to the industries and putting them to use by production organization through various modes of transportation. So every time movements is going on. Second is buffer inventory. Buffer inventory is what? These inventories are basically keep for future needs. Keep for future needs for the organization in stock, because there may a case when more inventories would be needed, and therefore every organization keep an average amount of inventories in stock, so that the organization can utilize those resources efficiently and effectively without any delay. That is buffer inventory. Third is anticipation inventory, right? Anticipation inventory, as the word indicate anticipation. So anticipation inventory are put under basically critical condition for future demand, so that when the time arrive, the supply of product flow rapidly, like producing raincoats before the rainy season. Fourth is decoupling inventory. Decoupling inventory, this type of inventory deal when the work rate of different machine and people. Okay, this type of inventory, again I'm repeating, this type of inventories, okay, deal with the work rate of different machine and people, because normal machines work at different rate, so some slow and some faster. Okay, some slow, some faster. So this is the inventory. Now the next inventory is what? That is the cycle inventory. Next inventory is what? Cycle inventory. Here in cycle inventory are those when purchase in a lot, you are purchasing a lot instead in exact amount of stock, right? You are purchasing more instead of the required amount in the inventory, right? But yes, if all purchase are made as per the exact requirement of stock, there would may have no cycle inventory. But then the cost is getting these stock would be much higher as per the customer. Okay. Next is inventory cost. Inventory cost, there is a storing cost, there is a holding cost, there is a purchasing cost in the inventory. So inventory cost basically is what? For deciding the best suited inventory policy, the topmost criteria used is the cost function. The inventory analysis has four major components. And what are the four major components in the inventory? That is the purchasing cost, ordering cost, right? Purchasing cost, ordering cost, setup cost, holding cost, storage cost. So what is the total cost? Purchasing cost, that is purchasing price per unit item. T is the annual demand. Ordering cost, how many order you are placing. So D divided by number of quantity you are order. D is the annual demand divided by number of quantity you are order into ordering cost per order. Average quantity in the inventory multiply holding cost. So this is the total cost. Okay. Non-destructive, basically it is a purely theoretical topic, so that will not come in your exam. So that's it for today's session. I hope everything is clear. Okay. Okay guys, thank you.